false, but negate it makes it true. Okay, so here's the final column on this one, and there's the final column on that one. So now let's see. Let's just do these one at a time. Are they logically equivalent? That means they need to match everywhere. Do these final results match here? No. So right off the bat, we know what? Not logically equivalent, okay? So logically contradictory, do they always have opposite values? Opposite, 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 opposite. So we just discovered that those two are logically contradictory. Does everybody understand that? Okay. But there's something else we can determine whether they're consistent or inconsistent. It's either going to be one of these or the other, okay? So consistent means there's a place where they're both simultaneously true. Let me see, is there a place, true, true, no, true, true, no, true, true, no, true, true, no. So they're not consistent, which means that they are inconsistent. Everybody got that? So we'd say these two statements are logically contradictory and inconsistent. Everybody got that? In fact, if you know the two statements are logically contradictory, they are necessarily inconsistent, okay? But I don't like people to try to make an inference based on the first thing to the second thing, because invariably people make mistakes, okay? So let's do some more here. Let me do number 2. We have M then P, M then P, and we have P or not M. P or not M. Okay, so let's make my truth table. I have M's and P's, so I'm going to need 4 interpretations to get all the possible truth values. Okay, 1, 2, 3, 4. True, false, true, false, true, true, false, false. Okay. So let me do this. M and P. True then true is true. True then false is false. False then true is true. False then false is true. So that's the final column for that one. Okay? So now I'm going to do this, P or not M. And I'm not going to do it in my head like this one. I'm going to write down not M first. Not M is the opposite of this. So instead of true, true, false, false, not M is false, false, true, true. And then I'm going to write the P column down over here so I don't have to look back and forth. True, false, true, false. So now I'm going to do the OR. And I get true, false, true, true. Do this. Okay. So now I've got the final columns for both of those, and now I'm going to ask, well, what's the comparison between these two? Okay. So first thing to look for is, are they logically equivalent? Do they have the same truth values for each interpretation? Okay, interpretation 1, ooh, the same, true, true. 2, the same, false, false. True, 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 true. They always have the same truth value, which means that these two statements are logically equivalent. Okay? Okay. And if they're logically equivalent, they can't be contradictory. But let's ask now this. Are they consistent or inconsistent? Consistent means there's a case, at least one case, could be more, where they're both true simultaneously. Line 1, this one's true, that one's true. What did we just discover? Consistent. Logically equivalent and consistent. Okay? And on the test, when I'm asking you to compare two statements, you're always going to tick one box, and sometimes you're going to tick 2, right? So you'll have to be asked this. So don't just say, oh, I discovered they're logically equivalent and stop, because we still need to know whether they're consistent or inconsistent. Does everybody understand that? Okay. And sometimes they're neither of these, but they must be one of those. You're always going to tick one of these two. Okay? All right. So let me do one more of these, one that involves more statement constants. Okay. So I guess I can do 3 if we want to just keep going in order. So 3. I'm going to erase them first. Okay. So number 3, we have C or H and L, and the other one is C or H and, or C or L. Okay, those are the 2. Okay, so now we have 3 statement constants. So now we have to figure out how many possible interpretations there are, and our formula is 2 to the n, where n equals the number of statement constants, 1, 2, 3. 2 to the 3rd is 2 times 2 times 2, which is 8. So we have 8 lines that we need to do. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Okay. Now to fill this in so that I get all the possible combinations, first of all, remember we put it in alphabetical order. That's our convention, so everybody's will come out the same. And we start over here and we rotate between true and false all the way down. So we get true, false, true, false, true, false, true, false. And then when we move over, we double it, so it's 2 trues, followed by 2 falses, and we repeat that pattern. So when I move over again, now instead of 2 trues, it'll be 4. So now I have all the possible combinations. So now we need to figure out the truth values for these 2 statements for all the possible interpretations, okay? H and L, okay? They're in the right order over here, so I'm just gonna do this without recopying the H and L columns, and it's an and, so I get true, false, 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 true, false, false, false. Okay. Now I will write the C column over here, which is true, 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 false, 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 false. So now I need to do the OR. Okay. So I'm doing an OR. So it's true, 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 false, false, false. And that's my final column on this one. So I get rid of all those intermediate things. Okay, so I'm going to compare that result with the result I get over here. First thing I got to do is C or H. So it's these 2. So C or H, true is true, 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 false, false. That's C or H. Okay. So now I need to do C or L. So it's these. So it's true, 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 false, true, and false. So I did this, I did that, now I need to do this final OR, and so I get true, 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 false. And let me scratch this out. Okay. So I've calculated the final column for both of those. So now we have to ask, well, what's the relationship between these two? Let's first check to see if they're logically equivalent. Do they give the same truth value for each line? Same, 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 same. Different. So they are not logically equivalent. Everybody got that? Are they logically contradictory? That would be opposites. No, they're not opposites, okay? So they're not logically equivalent, they're not logically contradictory. So we have still one question we can ask, consistent or inconsistent? Consistent means there's at least one line where they're both true. So let's look and see if we find that. True and true, what did we just discover? Consistent. Those two statements are consistent with one another, which means it is possible for both of them to be true at the same time. There is an interpretation in which both of them are true at the same time. Everybody got this? This is pretty straightforward. Any questions about this? Okay, we are going to have next period and all of next week to work, rework all these problems in chapter 3. You can see that chapter 3 is very, very mechanical, right? And that means that we should all get A's. Okay, all right. There is one more concept to introduce, and that is checking for validity by way of a truth table, okay? So let me, so I'm going to show you how to do that, but before we get going with that, we need to remind ourselves or tell ourselves what it means for an argument to be valid and what it means for an argument to be invalid. Okay?